So this is when we introduce Safevalues. So Safevalues, we like to call it a lightweight, opinionated library for writing trusted types, compatible and secure code. I say opinionated because it's a difference with trusted types. Trusted types, it doesn't really say what should be considered safe or unsafe. It just gives you the tools to capture what you think is safe, and what is not, you don't capture it as a trusted type. Safevalues, on the other hand, it's going to implement all the builders that will be captured as trusted types for you. So it makes the decisions for you. It's opinionated. So Safevalues, it's a JavaScript and TypeScript library. It's implemented in TypeScript. At its core, it implements a secure policy, and it exposes these types through builders that we call safe. And safe in this context, it means several things. Oh, previous slide, please. So it's either safe by sanitization. So you take an arbitrary input, let's say a piece of HTML, you pass it to a sanitizer, and whatever you get out is still a user-controlled input, but that has had all its script executing parts stripped. Or it can be saved by escaping. So escaping, you take some piece of HTML and you HTML escape all the characters, and for sure it won't execute any script. Or it can be safe by authoring. So if it's a compilation constant that the developer put in the code in the first place, this is also considered safe. Or you can also be safe by construction. So if you take two pieces of HTML that you trust that are well formed and you concatenate them, then in the end it's still a safe piece of HTML. Not all these approaches work for all the types. So for instance, you cannot create a sanitizer for JavaScript. If you're passed a piece of JavaScript, there's no way for you to sanitize it to make it safe. Like it doesn't make any sense. So for JavaScript, you can only have safe by authoring trusted script. And when you take all these builders together at Google, 99.3% of all the usages of these types can be covered by these builders. And all the rest, so all the corner cases that are hard to express, where it's hard to capture why a value is safe just with APIs, then this is when you ask for a security review and you have an actual human looking at the code, a security engineer. But this reduces the size of the review by a lot. Now, on the no, still previous slide, sorry. On the right side, you can see how Safevalues fits in your application. So instead of writing your application and directly interacting with trusted types, which would mean that you will write your own trusted type policy, you only interact with Safevalues, and under the hood, Safevalues is going to deal with the trusted types, let's say, level. And if you use another framework that is trusted type compatible and that has been security reviewed, maybe you don't need even Safevalues. Maybe you will only use the safe by design APIs from this framework. So let's say Angular is a good example. And this will take care of all the browser level interactions with the DOM APIs that are potentially unsafe. And maybe you are using a framework that wasn't built from the start with trusted type support, but in the future it was changed, and maybe it doesn't implement its own trusted type policy. Maybe it just uses Safevalues under the hood. That's also another setup that is possible. So how does Safevalues in practice look like? So I told you about different kinds of builders. And so you can see on the left, you can create a script from a template string literal. So that's a constant in the code. And it's not a plain string, like it's a constant that directly creates a safe script, which is like a trusted script URL under the hood. Or you can have the sanitize HTML that does sanitization, HTML escape that does HTML escaping, or you have other more exotic builders that take like an element's name, some attributes, and then the content, and it also creates a trusted HTML, and then you can concatenate everything with another builder. Now, on the right, you can see an example of what I told you before, the few cases, the 0.7% that cannot be expressed with a safe API. These are expressed with what we call safe by reviews APIs. And so for this, you bless a plain string to a safe type. But to use these functions, you need a security engineer to review your code and approve the commit or the pull request. Right. And now you may say, what if you don't have trusted type support on the browsers? Well, Safevalues is also useful for you because first, all these types at runtime, they will detect if trusted types is available. If not, they will just fall back to the normal string interactions with the DOM APIs. And since these types are safe by construction, and you also have the static analysis part that will make sure that you use these types instead of the plain strings, then your whole app is still by construction safe or only allows safe values to reach the sinks. So your app, even if it doesn't have runtime protection, should still be in a very good position because it's safe by construction or safe by design. Now, this is an example of how Safevalues assigns these safe types to the DOM APIs, and these DOM wrappers that we call, like set element inner HTML, they do they take your safe type, unpack it to a trusted type, and assign it to the sink.